The last bracketing method that we use for the optimization is the Brents method, and you know that the Brents method is a hybrid approach. In the root finding also, you remember that the Brents method was using the hybrid approach, combining several root finding methods in chapter 6, actually with the methods from chapter 5 and chapter 6 it was using. And in the MATLAB it was the f0 function which was using this Brent method in a more advanced way for root finding. A similar approach is used for optimization within the bracketing methods for the one-dimensional minimization, and it combines the slow dependable golden section search with the faster but possibly unreliable parabolic interpolation. It is said unreliable because parabolic interpolation can diverge, but the golden search converges, but it is not fast. But parabolic interpolation is fast. So what it does is it first attempts using parabolic interpolation and keeps applying it as long as acceptable results are obtained. So that's the basic idea. If no acceptable results are obtained using parabolic interpolation, then it uses the golden section search. It switches to golden section to continue in a reliable way, but a slower way. So this Brents method for optimization is defined in MATLAB as well as fmndbound function. This function, if you use this, you can easily use this for 1D optimization problems. And the function can be defined as this. The function is here and two initial guesses as the lower and upper bound. And it gives us the minimum x value and the function value of that. So the location of values of the minimum, function value, and x1 and x2 are the two bounds of the interval being searched. So let's check this fmnbound in an example in the following slide and implement it in MATLAB to find a solution for an example. In this slide, we have an example to use the fmnbound function in MATLAB. And this example is a bungee jumper example, and it actually jumps. And as you can see here, there is a trajectory of the function. It jumps and goes down actually. And this z is the altitude or the height of the jumper. And it is calculated with this formula. And we want to determine the time and magnitude of the peak elevation, so the maximum point we want to find. And we will use these parameters to calculate it. In the MATLAB, we can simply use this fmnbound as we said earlier, which is the Brents method, which uses the golden section search and parabolic interpolation. So we define the function with this line and the input parameters. Then we actually use this with starting with the 0 and 8 initial points. You can see here, maybe from graphically we can understand. If you first plot the graph, 0 and 8 is suitable to get a maximum in between. So that's why we decided these. You can change them as well. And z is the function. So the result is like this. X is 3.83 and function is minus 192. Basically, it's minus because it's actually calculating this in a negative way. But here we showed them in absolute values. And 3.8 is around here, and which shows a true value actually. And if we add here fmnbound the options as iterations to display, you can see the iterations as well. There are 9 iterations as you can see. It started from 3, moved to 4, then moved back to 1, then moved to 3, and got a good convergence here. The results are converged very well. And it started with actually golden search, it seems, golden section search, then move to the parabolic. So basic idea is to, with the golden section, try to go to the exact area a little bit further. Then from there, go with parabolic to have a very sharp result, which is accurate. And optimization is terminated, it says, because the current x satisfies the termination criteria using the tolerance of this. So the true result is very similar to the answer. You can see this is very simple to use this in MATLAB for an example.